Hello learners, welcome to TryRide. Learning further in Lambda expression and stream functions, we will be moving forward to Stream API. Stream API. So first we will see about the functional programming. As we have studied further all this programming, so we'll be having a look on all these things. Functional programming is a style of programming where functions are list class citizen that can be stored in variables, programs, path variables, which can be passed to R as an argument, and returned on the return from other functions. Yeah. Now in Java 8, suppose functional programming as introduced to, as it we have been introduced to earlier also. That lambda through these lambda expressions, we can see that we can see this functional programming and this functional interfaces also was this functional programming and stream API. This also supports functional programming. Now the goal is to make the code concise, shorter code, readable, that is easy to read and understand, and declarative, that will be giving a particular output. Now lambda expressions in Java. Lambda expression is a shorthand way of writing the program and implementation of functional interface. As we have seen earlier that when we are passing a parameter and following on the parameter, there is an expression which will be giving us a result. Like the parameters which are passed here, and in the curly braces, which is the body part, which will have all the operations performed on this passed parameters, and will similarly return a value, return result. It will return a value. Now coming further with no parameters, there can be functional programming where there no parameters are passed, like at the rate of functional interface, at the rate of which we have done with the functional interface programming. As in functional interface, we have to first declare that it's a functional interface or not, or it can be optional also, like the interface, and after that there is an interface by the name of the greeting, which has a body part, which is having a method. Which is having a method. This method, yeah, single abstract method. Yeah. Now coming further, we have the main class. The class name is example, which has the main method line, and following that main method line, there is a greeting. There is a greeting. This is greeting of type G. This is G. This is G type of greeting type only. This is the interface programming. Here in the interface programming, we have named as greetings. Yeah, greeting this name. This name only will make a type of it, and with this type, when passed to this functional body part, when this is passed to the body part, and suppose the output line is hello lambda as here, and after that we are calling say hello. Say hello is the method that is present in the greeting interface only, and similarly we can see the output. Coming further, we have with parameters and return type also, add in parameters and which are returning a value. When we have the functional interface as functional interface, at the rate of functional interface, which is the main, which annotation is, this annotation is optional, and after that we have the interface class. We have the interface adder. We have the interface adder here, which has the parameters as int add, which is of the int return type, and add is the name of that method, and parameters are int a and int b. The two parameters are int a and b, and for this adder, and calling this adder method only, adder interface only, we are returning a value of the sum. We are getting the sum value as a parameter. When we pass, the body will have the particular execution. The body will have the particular execution on the parameter passed, and then it will be turning the value when the parameters are passed. This parameter is work on the supplied parameters. These parameters when work on the interface that is called sum. That is the sum. This lambda expression. This sum, and will be adding the value of 5 and 3, and be producing an output as 8. Yeah. Similarly, on coming here, the lambda eliminates the need for anonymous inner class. This lambda will eliminate the need for the anonymous class. An interclass can make your code. Interclass is making our code much easier. As you can see that we have here the interface, and there is an interclass. There is an inner class which is making our code much shorter and which is much more readable due to this lambda expression. Yeah, and a return value also. Now coming to these functional interfaces, This functional interface is an interface with exactly one abstract method. We have seen that it is having only one abstract method. As here the method was, here the method is hello, say hello, which is the method, which is a functional interface here. Yeah, say hello, greeting. This is a greeting interface, and it has only one abstract method as say hello. Yeah, this is a greeting interface and has only one abstract method. Yeah. Now coming further, we have the functional interfaces. We we can use this at the rate of function interface, which is annotation, which is not forced to us. This is optional, but it is good and wise way to use this because it will say the programmer that is this is a functional interface. And so we have the boolean interfaces as predicate, which will return a boolean value. Then we have consumer, which will take input and return nothing. It will take an input but will return nothing. Then we have function, which will take input and return result. It will take input and return the result. Then we have supplier, which will provide a value, and then we have by function, which take two inputs and returns a result. It takes two inputs and return a result. Yeah, like the input as t and u, and it will return a result. Yeah. Now this interfaces makes it is easy for and this interface makes the program more easy as flexible and reasonable lambda based code, and so there can be reusable lambda based code which we can use after performing one function. We can use it for other function also, for other works also. Now coming to the introduction to this API. Now coming to this API. This API let us process data in collections in functions and declarative way. This API it will help us in processing the data from collections to a functional decorative way, and has the stream operations can be as these interstream operation can be filtered. They are the immediate and terminal. There are two type of operation. That first is immediate, another is terminal. The immediate compiles to filter, map, and sorted. And terminal compiles to forEach, collect, and count, and reduce. Now coming further, we have the stream pipeline. We have the structure of stream pipeline as collections to stream, then immediate operation, and following the terminal operations. We have the first collection dot stream, then there is dot intermediate operation, then there is dot terminal operation. Yeah. Coming further, we have the stream API examples as we have seen using the for each loop. Suppose there is a list of generic type string. That this name is the name of the list is names, and there is arrays as list of the names of the different names: Alice, Bob, and Charlie. Alice, Bob, and Charlie. They are the different names which are making up to this list names. And names for each, like for using the for each loop, we are making that names for each. Suppose there is a name. Suppose for the first name, if we have the first name, that is we have the various names passed here, and we have the functional part as body part as system.out.println hi plus the name. Here the name will pass and the body part will compile it to system.out.println hi plus the name provided. Yeah. Now coming on to filter plus collect. There is a list of generic type string. There is a list of generic type string. There is a generic type string, and the name of this list is fruits. Now arrays as list. It will provide a list of arrays. This provides as a list of arrays, and in this list, the first element will be apple, banana, avocado, and mango. Apple, banana, avocado, and mango. Now in this list, we list with generative string as a fruit. A fruits equals fruits.stream. They will be produced into a stream. Now fruits to stream, when they are filled, then the fruits will be produced as stream. We can further fix them with intermediate operation and terminal operation. Intermediate operations. Yeah. Intermediate operations and terminal operations. Then fruits will first will go up to that list. Then fruits which are in the list. Then the intermediate operations characters to filter. Yeah, intermediate operation can be corrected as filter also. And here for the name fruits, for the name of fruits, if the f means the fruit, single fruit. If the fruit name starts with a, if the f dot start with a, if the single fruit, that the fruit as among the list, fruits among the list, if they start with a, then there further follows dot collector. Collect. If they can be collected, collectors to list. They can be collectors to dot. Collector operations. For this we will collecting this list. For this we will collecting this apple. For this we will collecting this app fruit. For this we will collecting this fruit to these collectors. If the name of the fruit starts with A, then they will collector, then they will collector to the list, collector to the list. Yeah. Now finally we will putting the A fruit. A fruit means all the names that are starting with A. A fruit. A fruit means name is starting with A, apple, and avocado. Now following for the map transformation. For coming here, we have the generic type as a string, and the name of the list is upper. As fruits to string, we are again compiling them to a stream type. Stream type, following the stream type, we can map them first. We can map them first. Yeah. Now for mapping them, the stream will be making the stream to upper class. We're making the streams to the upper class. The streams is collections here, and we'll making collecting them to upper class. And finally then we will following the collecting part also, collector part also. For collector then map to string. They will first map it to string, and then they will collect it to the list. Yeah. Coming here, we have the system.out println of apple. First, these fruits will be converted to stream type. Stream type, stream type. The fruit will be connected first. The name of the fruit will be collected to uppercase. Then it will be collected as list. The fruits are first converted to apple uppercase letters. Uppercase letter here, apple, banana, avocado, and mango are all in uppercase letter, and then they will be collected to a list. Then will be collected to a list. Collected to a list. All the names, all the fruits we provided are now being collected to a list with the uppercase letter. Now sorted with lambda. Now coming to the sorted with lambda, we have the list of the string. We have this list string, which is a generated type of the string. Name is named with sorted. Sorted is the name of the list. And here the fruits are coming into the connections of the string. When the fruits are collected as strings. Now after being collected, they can be sorted. They can be sorted where A and B, A is compared to equal ignores case. A will be compared to the second upcoming second fruit that is in the list. Yeah. And after that they are compared means which letter will be coming first or coming first up basis of the letter, and then they will collect it to the collector. Then they will collect it to the collector to the list. Yeah. Dot collectors and collectors to list. Dot collector, and then coming to the collectors list. These all fruits will come in the list then only. Then we will printing the sorted list. Sorted as the name here we will provide name of this list. Sorted here is the name of the list, and here we can see that apple A, apple avocado A, then banana B, and then mango M. All the lists are arranged according to the name. Now coming to the count with condition. Now coming to this count, we have the long count. We have the count, which is a variable, and this fruits which will be converting first to the string function, and then for the first part we will converting a filter. If the fruit f for the length, if the length will be greater than for f dot length means the fruit length, single fruit length. If that is greater than 5, then count. If the single f means it is of the fruit type, and this f dot length, this will be count of the length of that fruit, and if it is greater than 5 or not, and then it will be counted. Then dot count will be counted. Then system dot out printed fruit which is more than 5 letters, that they will come in the count. Now we have studied here that lambda expressions. Let us write cleaner, simpler implementations of function interfaces. Cleaner and simpler implementation of the functional interfaces. Now this interface enables us to treat behaviors as data. This implement This interface help us treat this implementation part by treating the behaviors as data, and we are working on each and every part, each and every data according to this by using lambda expression and everything. Yeah, like here we are doing each data is counted by if greater than 5 or not by the lambda expression. Yeah, here. Now coming here, Stream API helps us to process calculations in functional, readable, and efficient way. It will help us in processing collections in the functional, readable, and efficient way. They are helping us in processing the collections as they are in list, and as they are helping us in processing collections as list and readable way. In readable ways, each and every data can be read and function and in efficient way. Now, together, these features allow us to read modern Java code that looks expressive and powerful. Together with this, together with the list and everything, list every collections and interfaces and Stream API, these are all the things will coming in combined, and they're allowing us to read and write this modern Java code that is expressive and more powerful way. Now we are coming to the end of this class. Now thanks, we'll meet in the next class.